everybody. In this video, we're going to be talking about a certain type of graph called a complete graph. So take 3 deep breaths and let's make this math easy. All right. So the idea of a complete graph is something we're going to use a lot once we get to Hamiltonian paths and circuits. And the definition of a complete graph is a graph where every single pair of vertices in the graph are adjacent. So basically what that means is for every single vertex, it needs to have an edge that attaches it to all of the other vertices. So like if we look at this one, the green vertex is attached to the blue and the yellow and the red. And the blue one is attached to the green and the yellow and the red. And the yellow one is attached to the blue and green and red. And the red one is attached to green and yellow and blue. So basically every single vertex is adjacent or shares an edge with every single other vertex in the graph. So this would be an example of a complete graph with 4 vertices. And typically, the way that we actually draw complete graphs is we arrange the vertices in a circle. And the reason why we do that is just because it makes it easier to let it be symmetrical. So this graph is actually the same graph as the one that I had on the last slide. It's just with the vertices arranged in a different spot. But the main idea is that every single vertex is adjacent to every other vertex in the graph. So if we look at these examples, these are some complete graphs on various numbers of vertices. So you could have the complete graph that has 1 vertex, or a complete graph with 2 vertices, or 3, or 4, or 5. And you can see they kind of make kind of cool pictures or patterns when you arrange the vertices in a circle. But even if the vertices are not arranged in a circle, if every single vertex is adjacent to every other vertex in the graph, then that means that it's a complete graph. We just usually tend to arrange the vertices in a circle because it makes nice symmetrical pictures like this. But you can do it even if you arrange them in some other order. So to practice this, why don't you guys go ahead and draw a complete graph on 6 vertices, pause the video, and then restart it to see how I do this. All right, so if you wanted to, you could arrange your 6 vertices in a circle, or you could also arrange them kind of in random spots all around the page. So maybe I'll draw these 6 vertices. And in order for my graph to be a complete graph, every single vertex needs to be attached or adjacent to every other vertex. So I'm going to maybe start with this vertex and make sure that it is adjacent to every other vertex in the graph. So it could look like that. Then I'll take this vertex and make sure that it is adjacent to every other vertex in the graph. And then I'll take this one and make it adjacent to every other one. I'll take this one and then this one. And so this would be a complete graph on 6 vertices. But if you were to arrange the vertices in a circle, then it would probably look a lot better. And you wouldn't have quite as much overlapping, and you would get a pretty symmetrical picture like what we saw on the previous slide. So that's the definition of a complete graph. It's a graph where every single vertex is adjacent to every other vertex in the graph. So I hope you guys have a good day, and that's it for this video.